In this lesson, we'll perform basic operations related to data exploration. First, we'll read all the price series data. These are carbon market, that is European Union Allowance Futures, ESG Fund, S&P 500, and Bitcoin data. Next, we'll visualize the data through various approaches to understand the basic characteristics of the data. In this video, we'll start our session by loading the relevant libraries, then reading the data and setting the working directory. So we'll start our session on portfolio analytics. For this particular session, the most important library here is portfolio analytics library. We'll load that. And then another very important library that we are going to use is Tidyverse. This is an advanced library for data analytics. Lastly, we'll also load library Patchwork. So now we have loaded the relevant libraries. Load the relevant library packages. Next, we'll set the working directory. If you are familiar with R, this is a very important step. In future, whenever you are working on this file, you need not remember the location where you have saved the data and all. By setting this working directory, look at this, set working directory, choose directory. Then in this particular location, I have all my data files. So I'll set it like this. And for record, I'll copy paste this particular command and put it here. So in future, I don't have to remember the location. I simply use this address, run it with Control Enter and set the working directory. Whether the working directory has been set appropriately, I can see on this file command. All my relevant files for this session are visible here and I can use them. In particular, two files I'm going to use in this session. First, I'm going to use asset price data, which is in this asset price XTS RDS file. When I click on it, a command has been run. Those who are new to R, you can just copy paste this command. So in future, if you need to read a data file, you can straight away go to this and run this command. This arrow symbol is as same as equal symbol. Assignment, this is called assignment operation. You can run this and you will have the data file. If you want to have a brief look at this, see the class. This is a zoo object. You can run a summary command on this. So if you put a summary command on this, and before doing summary command, let us do the head command. So we know what are the elements here. So since I have already worked with this data, this contains the prices and the year value. So it contains the prices of Bitcoin, S&P 500, ESG fund and UA futures. UA futures here is the carbon market, which we have studied. ESG fund is the one of the major ESG fund, and S&P 500 is a major index in US, and this is Bitcoin data. Along with that, I have put the year here and the date is marked as timestamp because it is a zoo object. Date is not a variable, it is just timestamp to all the observations. This is a unique feature of zoo object and we'll make use of it. You can also run the summary of this object to get the summary of prices. That is very easy, but we'll have more idea about this with visualization. Also, you can see the structure of this object with this structure command. You can see what are the objects. You can see it's an XTS object with the number of elements. See, there are 753 rows and 5 columns. These columns include, as we saw, 1 year column and 4 data columns. You can see their properties very well in detail here. For example, there are more such commands where you can examine your data. Starting with, let me show you some of the very good and important commands. You can check the dimensions with dim command. You can see the dimensions of, this is often called a data frame also. This X2S object is in a data frame of form. So you can see there are 750 rows, that means 753 daily observations and 5 columns. You can also run this glimpse command, a very useful command, which is part of this Tidyverse package as part of dplyr. You can run this glimpse command and see a brief overview of this data. Similarly, another very important aspect of this analysis would be return data. So we'll load the return data in a very similar manner. I'm copy pasting this command also for our reference. Now, in a similar fashion, the way we have run the price data, we'll also use the return data, and I'll just copy paste these commands. I need not type them again. So for example, I can check the class of return data. Again, it is an XTS Zoo object. Then I can also see the head of this. So you can see some initial observations. These are returns for Bitcoin, S&P 500, ESG fund, and UA futures carbon market. So these are return observations. You can also run the summary command to see a brief summary of returns. See, so we have the minimum first quantile, median, third quantile, and max for all the Bitcoin, ESG fund, S&P 500, UA features their returns. We can also check the structure of this data, which will be pretty similar to the price data. You can check the structure. It gives us all the details. One observation is less, which was consumed while making returns. So there are 752 observations. I can also confirm this with the dim object. Lastly, I can also run this glimpse object to have a brief overview of the data available at hand. So with this, we conclude the first set of video where we loaded the data. We set the working directory, loaded the relevant packages and libraries that are to be employed. And lastly, we also did a brief summary of our data that we have loaded. Starting from the next video, we'll move on to visualization session for a greater understanding of our data. In this video, we'll continue with our data visualization session. We'll be using ggplot function, which is one of the most advanced version of what we call as grammar of graphics. This is the most advanced version of plotting data in a very simple manner. So first, we'll create a ggplot object, ggplot. We'll make use of our asset prices, which is asset price XTS data. Let us make it slightly more simple as asset. So I'm creating a new name or a copy of this data, which is asset. I do not want to disturb my original data, which is a good practice. So first we'll give the name asset. Next, you need to specify the aesthetics that you want to plot. So I want to have on x-axis the dates, which is extracted through this index command. Through index function, I will extract the dates from my asset object. It's a time series zoo object, so it's easy to do this through index command. Then I want to plot the time series of bit. So in this particular video, we'll see how to plot the time series of prices. So first we'll plot it for the Bitcoin. So we have the object name as bit. So I'll use y equal to bit to specify my y-axis. In the next layer, so this is my first layer. So if I run this layer, you'll notice a sort of empty plot is created. I need to specify what kind of plot I want, which I'll do in the subsequent steps. So in the next step, I'll specify that I want a geometric object in the form of line command. So I'll run this line command and I'll specify a color which is blue. I want a blue color line here. So I'll specify this. Let me see what comes out of this. So notice a red line, a blue line has been plotted here. We can see the price over time from 2018 to 21 of Bitcoin in blue line form, but this needs to be improved much more. So for now, all we'll do is we'll add some access also. So the access can be added with this labs function where I'll use title as the central title as Bitcoin. So I'm improving my chart a little bit. Also, I want to keep my y-axis empty, so I'll not use anything on y, which is done simply by specifying a blank between quotes. So there's nothing. On x-axis, I would like to add the date. So now if I run it, a very nice plot will appear and I'll save this. So this is a nice plot with all its dimensions and I'll save it in the form of P1. So my P1 is created. Now for P2, I'll not rewrite the full thing. I'll just copy paste the same command. And the second graph that P2 that I'm going to use is of ESG fund. So here instead of Bitcoin, I'll have ESG fund. I rather will use a different color. Let me use the green color here. And I'll specify on the heading also that this is an ESG fund. And I'll save it as P2. In the third step, P3, I'll use my S&P 500. So I'll specify it as S&P 500. I'm using the exact name as in my data. So if you want to check, you can just do a head command and you'll find the exact names. Bit S&P 500, the same I'm using here. However, for setting up the axis name, I can choose as I wish. So this is just character to represent the axis. So I'm just putting as I find it more suitable. So this is, and I would like to have a different color, maybe red color. I want to keep these colors separate. The last one is UA futures, which is the carbon market. So these are the 4 data points that I have used. So this is UA futures. So I'm making use of these 4: UA futures, Bitcoin, S&P 500, ESG fund, these 4 dimensions, and I'm plotting them along the date. So I'll use here UA futures, which is essentially the carbon market data from ICE ECX, which we have already discussed. I may use a different color, maybe black here as a color, and this will be my P4. So I have all the plots starting from P1, P2, P3, P4 ready. Now if you notice, we have initially at the beginning installed a patchwork library, which will help us in drawing a very nice plot. So for example, I'll run this P1 plus P2 plus P3 plus P4, and it will draw a very nice looking plot for us, as you'll see, though it would require some further changes. So you can see a very nice plot, but it requires some changes, some improvements, which we'll do through this very interesting command called plot underscore annotation. Here we'll specify the central title for the plot, which is time series of prices. So this is our main theme here. Then I need to specify a little bit about the dimension of this plot. So this is done through the theme argument, where we'll specify the theme as plot the title. So we wanted to set plot the title with certain dimensions. So these dimensions are element dot underscore text. This is a very useful argument, element underscore text, as we'll see. So in this element underscore text, I'll use, first and foremost, I'll adjust it is adjusted by half, so it will come into the center. So I'm setting with this adjust, which is horizontal adjustment by half, so it will come in the middle. I'll increase the size to 20, so the heading, central heading, looks a little bit bigger and its font as bold. So now let me adjust the command a little bit so it is visible to you on my screen. So now if I run this plot, let me run this entire command, and a very interesting plot will appear, as you'll see, a proper nice plot where we can see the price movement of, and I can zoom it for you. So let me zoom it. So you can see now the price movement, the time series of prices for Bitcoin in blue, ESG fund in green, S&P 500 in red, and UA futures in black. And you can see sort of their movement over the 3-year period from 18, 19, 19, 20, and 2021. A very nice looking and very useful plot is appeared, where you can do all the visual analysis of the data. In the next step of visualization, we'll see the movement of all the price series with S&P 500. So we'll visualize with S&P 500 movement. S&P 500 is often referred to as the indicator of not only US but global economic movement, and therefore how all the price series behave along with S&P 500 is very important. We'll sort of conduct some kind of regression visualization, how these series are moving with S&P 500. We'll again follow the same technique of ggplot, and we'll use this asset price, asset object. We'll specify our aesthetics as, on the x-axis we'll always have this S&P 500 values, because we are looking at the movement or regressing the series on S&P 500. On y-axis, let's start with the Bitcoin. So this is our first step that we always use. Notice that when I run this command, again an empty layer will be created, empty layer of plot will be created, but we need to do a little bit more. So first and foremost, we specify that we want the scattered form. We'll plot the scattered form through geom point. This geom point will create a scattered set of objects, which we'll use in red color. So you notice the relationship between Bitcoin and S&P 500 is plotted in the form of this jittery red scatter dots. But we'll also add a geom smooth. Now this geom smooth is in the form of a regression line, we'll put it a color of blue so that we can differentiate it. And the method is LM. LM is simply for linear modeling, so it will be a straight line, which is the OLS regression line will be plotted. So if I run this, you would notice that a straight line will be run with the formula of simple regression here. This y tilde x, you can see the regression line in blue moving from one end to other. Now let us improve this plot as we did earlier with the labs command. So with labs, we'll specify some of the axis detail. For example, the title of this plot is Bitcoin versus S&P 500. So this is our central title. On the y-axis, we have Bitcoin, and on the x-axis, we have S&P 500. So this will improve the dimensions and aesthetics of our plot, and a very nice looking plot will appear for us. And we can save it as the object P1. Now, like we did earlier, rest of the objects we'll create in a similar manner. So I'm not showing them all of them. I'm just copy pasting the steps. So in P2, we can have ESG fund on y-axis, ESG fund on y-axis, and I can specify the color. Maybe I'll give it a name as ESG fund. Let us use the same color. It doesn't make much of a difference. So I'll use ESG fund. All that I need to do is change here ESG fund here as well. So these are not necessarily the same variable names. I'm giving them as I wish. Only that I need to be correct here in this particular, because this is picked from the variable name in our data asset. So it needs to be correct as it is as they are in the asset. And you can check it here with this asset head asset command. You can see the initial few names, and if you're coding along with me, you can see here ESG fund. This has to be exactly same as here, and S&P 500, which needs to be exactly same as this. Again, in the next step, now that we have done for ESG fund, our P3, I can choose the P3 as maybe UA futures. This is the last one, so UA futures. And in this UA futures, I can again just specify that this is UA futures. And here on the y-axis, I can specify that I have UA futures. So I'm ready with my plots. Now I'll run these commands. All the objects are created. I hope that they are error free. As we can see, they are error free. So now all I need to do is, because of that very useful library patchwork, I can just specify P1 plus I want P2 plus P3. And let's see if they are created. So now they are sideways. So if I run P1 plus P2 plus P3, they are sideways in this fashion. But you can zoom them. You can zoom them to have a look at the plot, and you can see a very straight line kind of relationship between S&P 500 and all the other three securities, that is Bitcoin, ESG fund, a very straight line on average, positive sloping, which sort of gives us some idea about this relationship. As we can see here, there is a positive relationship. Also, if you want to, you are not very comfortable with this kind of presentation, you can put a slash, which will give in the row form, which will present our plots in the row form. Depending upon your comfort and your taste and preference, you can have a look at like this also. So this is also another way of representing the plots, where we can see the relationship of S&P 500 with all the three securities in a very nice aesthetic manner. So in this video, we visualize the data. That was our second step of visualization. In the next video, we'll have a look at the density plot of all these securities. In this step of data visualization, we'll examine the density plots. Density plot examination is very important because often we have this assumption of normality or some specific distribution about data, which we'll employ while modeling. Therefore, it is good to have a visualization of data densities to see how correct or accurate we are about the assumption about the distribution. So we'll make use of density plot to visualization of data. And as we did earlier, again, we'll make use of ggplot command. First, we'll specify the asset object. Then first we'll do for Bitcoin. Notice I want to have the density visualization across different years. So I'm using this factor year, which will specify each year as a factor, individual year as a categorical variable. So each year will be used like this, and then I'll also use the fill as factor. Fill also as factor here. So I'm using the color, and also as you'll see the boundary lines of those density plot will be specified through different colors for different years with this command. So I specified my aesthetics. In the next step, I'll specify that I want the geometric object in the form of density. So this will specify that I will keep the line width. Width is a useful sort of argument. And then alpha is to ensure, so many times it happened that there'll be overlapping plots. So alpha will ensure that there is a reasonable amount of transparency. So even if they are overlapping, we can have some idea about what is happening in the plot behind. And lastly, as we do, we'll add the labs command to specify our title. So in this case, the title is Bitcoin, and I'll keep my y axis as empty, x axis also as empty. My aesthetic is mapped to year, so I'll map my aesthetic to year, and also the fill aesthetic is also mapped to year, so I'll put as fill also as year. So we'll just see if we have run the plot correctly, and to get some idea, yeah, the plot is run correctly. So now all we need to do is save this object, and in a similar fashion create the similarly create the object for other security. So because this code has run properly, we'll create P1, and as we know, we'll then create for P2. So P2, let us have P2 as maybe UA futures. So I'll use the next security as UA futures. I'll use the headings appropriately here as UA futures. My next P3. P3 we can plot ESG fund maybe. So I'll use ESG fund here instead of UA futures. In P3 I'll use ESG fund. I'll specify here also that my title is ESG fund. That is my P3, and parallelly I'm running with control enter. Pressing control enter, I'm running all these commands. Lastly, P4 I have S&P 500, so I'll write S&P 500 here, S&P 500. So this is my last. So so all you need to do is run all those P1, P2, P3, create these objects P1, P2, P3. Now that you have created these objects, let us see how they appear when I print them. So P1 plus P2 plus P3. So you can see, I'll make some space. So you can see I have put all these P1 plus P2 plus P3 together. If I plot them, a very nice density plot will be created with all the four objects. Though some improvement is needed, I need to improve their headings and all. So it'll appear like this, but some improvements are needed with the labs command as we have been doing. So plot annotation command rather, because now we are doing the central heading and all. So central heading is created with this title, density plot year wise. So this is our central title, but also we need to provide its dimensions. So first dimension is theme, very important dimensions. Through theme object we'll create theme, and as you recall, we use this plot that title, and title element text, we often use this element text to adjust our central heading by half. We'll make it center with this 0.5. Also we'll increase its size related to other access labels. We'll increase the size a little bit. By practice I know, by experience I know, it is 20 will do the job, and then we'll slightly highlight it in the bold font. So this will do the job. So let me run this, and often when you run the plot, you need to enlarge a plot window. And once we run the command, a very nice looking plot is appearing here. Let's zoom it on. So it appears like this. It's a very nice plot where we have the density distribution of all the four securities, that is Bitcoin, UA futures, S&P 500, ESG fund, and we can see how they are distributed. Some of them are, so we can see these are not necessarily normal. So some of them are skewed, and some of them are bimodal. So prices are often considered to be log normally distributed. though we can see here that this is not exactly the case. The price distribution is slightly, though I have plotted here in raw form, and you can see that it's not a very nice bell shape. It gives you some broad idea that there is some skewness and all those things. And you can have a good idea about your data by plotting the density plot like I have done here. And in fact, I have plotted them separately year-wise manner. In the next plot, we'll have in next data visualization exercise, we'll have some more idea through plotting them in the box plot to see whether there are some outliers and how data is distributed across here. In this video, we'll conclude our data visualization exercise with box plots. Box plot is a very important tool to see the distribution and scatteredness of data and also identify the outliers. So we'll conclude our data visualization exercise with box plots. So to begin with, we'll again follow the same convention of using ggplot asset, and we'll specify our aesthetics, which includes individual series. So on y-axis we have UV features. You can have also on x-axis. I find y-axis to be more convenient. In this case, you can have x also as UV features. So fill, again I'm using factor here, so that factor will convert here into a categorical variable. Then you need to tell R that what kind of geometric object you want. So in this case, we know that we want box plot. So very easily we get this box plot exercise. And then let me show you what exactly we get out of this. So when I run this command, we get this kind of object. So we have 3 years. On the y-axis we have UV features distributed for 3 years in different colors. For example, 2018 is slightly reddish color, green for 2019, blue for 2020. Let me improve this further. Before we discuss this a little bit, as we usually do, we add this labs command to fill, and notice this aesthetic is mapped as factor year. So I need to specify this fill should be mapped as year. So this is nicely printed as year, and also the title as UV features, and I'll specify the y-axis. We can clean it. So now if I enlarge the plot, let me enlarge it, and a very nice plot will appear. So you can see the plot here being printed. Now this is a box plot. For 3 different box plots are there. The base of this box plot is the first quantile or 25 percentile. The central line of this box is the median observation. So this represents the median. The top is 75 percentile. 75 percentile. So between 25 to 75 percentile, almost 50% of the observations are here. The whiskers that are here, these are the whiskers, and the observations beyond the whiskers, if there are any, they are called outliers. There is a certain formula to calculate the length of these whiskers, which is nothing but starting from this 75 percentile, if you add 1.5 times what we call as interquartile range. What is interquartile range? IQR. IQR is nothing. Let me write it in the form of comments. IQR is the difference between 75 percentile line minus 25 percentile line. So this difference IQR, when it is added on the top and subtracted from the bottom, these represents the whisker length. So whisker length is what? 1.5 times the interquartile range. And any observation beyond these whiskers is called extreme outliers that vitiate our estimation. So this is how you interpret the box plot. The base is 25 percentile, the top is 75, the line inside at the center is the median line, which represents 50 percentile, the center of the data. And beyond that, you have whiskers, which are driven by a certain formula. Any points beyond these whiskers are extreme outliers. So as we do often, we'll assign this to our plot object P1, and we'll create all 4 objects for all our data. So this was first object. Our second object would be, we can take probably Bitcoin. So let me use bit. Bit is the name of the variable for our Bitcoin data. So this is our P2. Similarly, we can run P3. P3 probably we can use ESG fund maybe. So I'll use ESG fund here. ESG fund, ESG fund, and lastly P4 we can have S&P 500 data. So on P4 I can have S&P 500 data here. We can write S&P 500. I'll run all of them. So I have all the plots run. Let me see if I have them run error free. Yes, I have. So we have run them successfully. So now first I'll show you the plots in the raw form before improving them aesthetically. So let's see if I run this P1 plus P2 plus P3 with the patchwork library that we have installed earlier, a very nice plot will appear here. So you can see all the plots. You can see the sort of, if you look at year 2020, generally the prices are on the higher side, so which shows the gradual increase in prices. That's why the distribution of the blue, which is for 2020, slightly on the higher side, and 2019 is on the lower side. Also, you can see the observations of blue one are slightly more scattered, which indicates the effect of COVID, because there was a lot of volatility and fluctuations in prices due to COVID that is appearing in the scattered nature of the diagram, particularly the outliers for Bitcoin. You can see a lot of outliers here, and in the ESG fund also there's a lot of outliers which indicate the COVID driven fluctuations. But let us improve our diagram further with that plot underscore annotation command. So here we'll specify the title as box plot year wise. Then we need to specify our theme object, and we have seen that we have done that multiple times now. So we'll specify the theme. First we specify the plot dot title with element underscore text object, and here first we put the adjustment, horizontal adjustment, adjust equal to 0.5. we also add size, we increase the size to 20, and face to bold. So we have a very nice looking diagram coming right away for us. I'll run this. So with this layer by layer, we have a created very nice looking diagram here for all the 4 securities box plot. You can put more focus here. In the absence of time, we are not doing it here, but you can just spend some time looking at this graph, have a look at this, see what sense you can make or what you can infer about the distribution of observations. I have already explained how to interpret a box plot. So you can compare not only across years, but also across securities. For example, you'll find that if you look at Bitcoin, there's a lot of scattered nature, which indicates there's a lot of volatility, particularly in the year 2020. In fact, in the year 2020, the blue one, there is volatility across all the securities because of COVID. So all those things you can have a careful look at the diagrams and infer about the security prices. In this video, we examined the box plot and we concluded our data visualization exercise. From the next set of videos onwards, we'll perform the portfolio analytics. With the help of portfolio analytics package, we'll do the portfolio optimization and portfolio construction with returns data. To summarize this lesson, we performed the following tasks. First, we loaded the relevant libraries. Then we set the working directory. We started by reading the data from the appropriate location already set as our working directory. Then we checked the class of the data, initial few rows, and also examined the summary, structure, and dimensions of the data. Next, we visualize the data with ggplot for each price series, including EUA futures, Bitcoin, S&P 500, and ESG fund data. Next, we visualize the linear relationship of all the 3 series, that is carbon market, ESG fund, and Bitcoin with S&P 500. Next, we examine the distribution of each series with the help of density plots. We concluded the visualization exercise of the data with box plots.